Welcome to Study Loop.
You can find the temperature of the refrigerant at 140 kilopascals in the corresponding table. It's approximately negative 18.77 degrees Celsius. Let's first find the coefficient of performance of the refrigerator. This formula is taken from section 11.2. The formula number is 11-4. Here TH is the temperature of the heatsink. TL is the temperature of the low temperature source. Please note that TH and TL are in kelvins. So we have to convert TH and TL from degrees Celsius to kelvins by adding 273.15 to these values. To answer questions B and C, let's first find the amount of thermal energy per 1 kg of the refrigerant that's rejected in the heatsink in process 2-3. In order to find the amount of rejected heat, let's find the difference between the enthalpies of the refrigerant in states 2 and 3. So in state 2, the refrigerant is a gas at 60 degrees Celsius, and at state 3, it's a liquid at the same temperature. You can take these values from the table. The answer is approximately 139.09 kilojoules per kg. This is the amount of thermal energy rejected by the heatsink. Now, because of the conservation of energy, the amount of energy rejected by the heatsink is equal to the sum of the work performed by the compressor and the amount of thermal energy absorbed from the low temperature source. By definition of the coefficient of performance, the coefficient of performance is the ratio of QL to Win, where QL is the amount of thermal energy absorbed from the source and Win is the amount of work performed. So we can substitute the expression for QL into the first equation, factor out Win, and then isolate Win. Win is now expressed in terms of QH that we already know, and the coefficient of performance, so in terms of the known quantities. To find QL, you can take the expression for Win and substitute it into the second equation. QL is now expressed in terms of the known quantities.